if you are landing here directly without knowing simple linear regression, I strongly recommend to watch our previous sessions, that is simple linear regression, because understanding of simple linear regression is a must for understanding multiple regression. So let's start. My name is Savyasachi. So this is a series of videos we are posting to learn data science basically. If you are well aware of statistics as well as all the formulas, then no need to worry about these videos. You can jump to other sessions. So today we are going to discuss about we will learn what is meant by multiple regression. So let me simply walk through you what is meant by simple regression. So when we know the independent variable data and dependent variable data, when we have one set of sample data that contains independent and dependent variable, then when someone gives you some random input independent variables, then by using our simple linear regression, y equals to f of x, that is y is the predictive value function of x basically. That is a simple linear regression equation. So by using our simple linear regression equation, we will try to predict the value of dependent variable for given random independent variable. That is what we learned in our simple linear regression. So we learned about what is the equation of simple linear regression and how to find the upper limit and lower limit for a given mean, that is the band of predicted value and mean value. Now we are trying to understand what is meant by multiple linear regression. So multiple linear regression is an extension to simple linear regression basically. So if you understood properly simple linear regression, we dealt with one independent variable and one dependent variable, right? So in our previous example, our independent variable is your income, where your investment is dependent variable. Based on given random income value, we tried to find the predicted investment based on your income value. So here we dealt with only your income value as independent variable. That will be fine in many situations, but there will be some situations where we need to deal with more than one independent variable to predict one dependent variable. Understood? Whenever we require to predict the dependent variable based on more than one independent variable, then we will go for multiple regression. So the same type of equations, same kind of thumb rules will apply to multiple regression also. So as we know, the simple linear regression equation is y cap, that is predicted value equals to beta 0 plus beta 1 x plus c, that is our model. In our case, in multiple regression, y cap, this is our dependent predicted variable. This is what we are going to predict, beta 0 plus beta 1 xi. So beta 1 is first independent variable iv1 plus beta 2 xi2. So beta 2 is your next independent variable. So this can be up to beta n xi plus e. E is our random e is our error. So this is our multiple regression model basically. So the equation of e of y equals to, this is the linear equation, beta 0 plus beta 1 xi x1 plus beta 2 x2 plus beta p xp. So this is our multiple linear regression equation. So if you see up to this beta 1 x1, this is simple linear regression. We extended for other independent variables, that x2 xp, until x from x to xp. So this is extension of our simple linear regression. So in our multiple regression, we are going to deal with multiple independent variables, right? In that situations, we should do some step. So we should follow some steps to determine what independent variables we should consider to before we write this equation. Basically, in this equation we can keep multiple independent variables, right? x1, x2, x3 up to xp. But while dealing with multiple regression and multiple independent variables, we will face many problems. Basically, when we are dealing with data, you will face many problems. Basically, that is, first problem is overfitting. Overfitting means when you are including multiple unnecessary independent variables, it will lead wrong results. So we should identify what are the actual required independent variables to be considered before we calculate our equation. Second one is multicollinearity. Multicollinearity means, in our case, if for example we are including 3 independent variables, let's imagine, if those independent variables are not dependent, there is no correlation between these 3, there is no linear relationship between these 3, then there will be no problem. But for example, x1 is your independent variable 1, x2 is your independent variable 2, x3 is your independent variable 3. Then if x1 and x2 have some linear relationship, and x1 and x3 have some linear relationship, then all these 3 values have some linear relationship among themselves, among independent variables. Then we will face many problems, unnecessary. It will create complexity, as well as it will lead to wrong results. So we should not be overfit, and we should careful about multicollinearity. So remaining things all are same as simple regression equation. So the basic thing here is, while doing with multiple independent variables, first we need to identify what are the data we have. So let me write down. So first thing is generate what all our dependent variables and as our independent variables. So this is required for as well in our simple linear regression also. First, whenever we got some data, we should identify what are our dependent variables and what are our independent variables. So then once you know the dependent variable and independent variable, then using scatter plots, try to find, is there any relationship between IV and DV for all the independent variables and dependent variables. So this is, do a scatter plot for given all independent variables with our dependent variable. Third one is, do a scatter plot between independent variables, among independent variables, IV1, IV2, IV1, IV3, IV2, IV3, like this. So we need to find what are all our dependent variable and independent variable. Then we need to use our scatter plots to find the relationship between independent variable and dependent variable. Third one is using scatter plots, try to find what are the relationship between among independent variables iv1, iv2, iv1 with iv3, iv2 with iv3, like this. If you have multiple, then you need to repeat this process for all the independent variables as well as for independent variables. So you need to find the relationship and correlation basically. Then once you done this, you will know which one is redundant. That means repeating multiple times. So we should avoid those redundant data from our equation basically. For that reason, we should identify we should do this process to identify the proper independent variable. So basically our independent variable explains the dependent variable, right? Our independent variable explains dependent variable. That's why our first goal should be to identify what are the proper independent variables. Then only we can explain our dependent variable properly. And we can come up with some proper linear equation. So once you done these three things, then you need to apply our simple linear equation, that is y equals to b0 plus beta 1x. Same thing for one independent variable, for second independent variable beta 1 plus beta 1 x2. So you need to perform simple linear regression equation. After that, as we discussed, we know how to calculate SSE, SST, MSE, SSR, as well as MSE and standard error. S is the root square of MSE, right? We already know, and we know how to calculate those values. If you are not aware, you can watch our simple linear regression equation. We discussed how to calculate these values. So once we identify these independent variables, required independent variables to be considered in our linear equation, then you need to repeat this process for each independent variable. And the final point is you need to find the standard error, that is root square of MSE, mean square of error MSE means. So once you know the standard error out of these independent variables, you should if the standard error is lesser, that independent variable we will consider for our equation. Once you calculate this standard error for each independent variable, then for which independent variable the standard error is less, then that independent variable only we will consider while doing our multiple regression equation. Other independent variables we can ignore basically. So this is in theoretically we till now we explained, we learned. Just now let me explain one real world scenario. We will continue our sample problem only, like whatever we used in our simple linear regression. Your income is your independent variable, investment is dependent variable. Based on your income, your investment will be decided, right? In this case, let's try to add another value, your health. Your income as well as your health defining your investment. Let me add another independent variable, your income plus your health plus your height. For example, if someone gives this kind of data, your income, your health and your height, explaining your investment. So our income plus your health plus your height, these three values explaining your investment. So in this case, if we are given this kind of data, this kind of sample data, these three values are defining our investment. That means these three values data we will call it as independent variables. So whereas our investment is depending on these three, combination of these three, that means we will call this investment as our dependent variable. So our problem is we are going to predict this investment if we are given some random input independent variable. That is what our linear regression basically. So in our case we have income, health and height as independent variables and your investment is dependent variable, right? So our x1, x2, x3, this is our dependent variable y. So first we will draw as don't ఇక్కడికి రా, పడిపోద్ది అది. నువ్వు చెప్తులే తర్వాత, నేను చెప్పమన్నప్పుడు చెప్తా. నేను చెప్పాక నువ్వు చెప్దు. నేను ఎలా చెప్తున్నావు అలా చెప్తా. So we will first draw one matrix with independent variable 1 our income. Second one is your health, third one is your height. This is our investment. పడిపోతాం దిగు. నేను రాసాక మళ్ళీ ప్రాబ్లం అయిపోద్ది, అక్కడ రాయకూడదు. సో we should identify all this data basically, x1, x2 and we need to draw some other columns also to x1, x2 combination of y with x1, x2, y with x2, x3, those kind of matrix we should write, and we should plot, we should find all the standard errors for each and every equation. Not only for let me write down once again, x1, x2, x3. So we will find this combination dependent variable y and x1, then y dependent variable x2, y dependent variable x3, y dependent variable x1 as well as dependent variable x2, y dependent variable x1 dependent variable x3, y dependent variable x2 dependent variable x3, y dependent variable independent variable 1 independent variable x2 independent variable x3. So we should calculate all these scenarios, we should consider all these scenarios to find out proper result basically. So this much complexity we need to face when you are dealing with multiple independent variables. You need to find out all the scenarios basically. But don't worry, when you are calculating with manual process, then we will take lot of time. But when you are dealing with Excel or Minitab or other tools or Python, you can do it very easily. ఇది చేశాక నేను చెప్పేశాక చెప్పాలి, చెప్తాను అప్పుడు. So in our case what we are doing, we are dealing with income is our first income is our x, right? Our y is investment y. So if you చెప్పిన మాట వినాలి, కూర్చో ఒకసారి. నేను చెప్పిన అప్పుడు సరిపోద్ది, నేను చెప్తాను మళ్ళీ డ్రాయింగ్ అయిపోయాక. So here if you plot our scatter plot between income and our dependent variable investment, you will find some linear regression, linear like model when you do a scatter plot. When you do a scatter plot for your health and investment. In this case also your health and investment will find one linear relationship, strong or weak linear relationship. But when you plot a scatter plot for with height with income as y dependent variable, then you won't find a linear relationship. This can be something else. So first point is, as we discussed, we should find the graphs of scatter plots of our all independent variables with our dependent variable. So when we notice these graphs, we can say our income as well as our investment have some linear relationship, as well as our health and income has some linear relationship. But when it comes to health, there is no linear relationship. We can't find, by seeing this data, we can't find there is no relationship. So we won't consider health in our equation, the first point. So now we will erase this health data. Now we will come to this income and health. So as I earlier said, when we have more than multiple one independent variable, then we should find out whether these independent variables have any relationship among themselves. If income and health have some linear relationship among them, then we are going to face problems, right? Our equation won't be proper. So to know that, first we will draw a scatter plot among income and health. If there is a linear relationship, if you find a linear relationship, then what you need to do is you need to apply our simple linear regression, and you need to find the standard error for each income and health, and which standard error is last లో వచ్చామ్మా 6 minutes ఉందా అది ఛార్జింగ్ ఒక్క నిమిషం ఆగమ్మా. So in this case, income and health are proper, we consider. Now we are trying to find whether this income and health has some linear relationship or not. If you find some linear relationship among income and health, then you need to calculate the standard error, basically standard error. Yes, if your income data standard error is less compared to health standard error, then we will consider only income instead of health also, right? You understood? Let me once again repeat. So first we identified the relationship between our independent variables as well as dependent variables, IV1 and IV2 and IV3. So in these both cases we found some linear relationship, but in this case there is no linear relationship, so we eliminated this IV3. Then we are trying to find whether these two have any multicollinearity, like whether these things, both things are repeating, there is no need to redundant, then there is no need to include these two independent variables into our equation. We should try to find one independent variable so that our equation will be proper and our linear regression equation will go through our centroid, basically. So to find out which independent variable we should consider, first we will plot one scatter plot. If you find any linear relationship between among these, then you need to find the standard error for this independent variable, standard error for this and the second independent variable. If which value of standard error is less, that independent variable only we need to consider in our equation. So I hope you understood. This is multiple regression. So this multiple regression is the extension of simple linear regression. So to calculate this S or B0, beta 0, beta 1x, all these things we done in our simple linear regression equations. So before understanding multiple regression, we should understand our simple linear regression. Thank you.